Great to see you back for lab 2. So this time we implement a service task, so basically the logic behind the service task. So if you think back of operate, of the one process instance we approved, this is currently waiting for celebration. So how does this work? You have a couple of different options. Actually, there are more programming languages that are supported, but I focus on Java, Node.js here, and probably also have a quick look at C#. So you can basically select the language you're familiar with, and this lab requires that you have the environment already running on your local computer. So it doesn't go into any of these details, okay? So for example, if you go into the demo Java worker, basically you have a small Java project. I have that open here in my IDE. As you can see, there is not that much you have to do. So it's basically a worker which uses the Spring Boot integration to connect to the celebrate service task, and then some code is executed whenever a process instance is waiting for a celebration. And this code could read, again, process variables could read data from the context of the process instance. It does some real business logic, which in my case is a system out print line. And then we basically let the workflow engine know that we're done with the task, so that the process instance can move on in the workflow engine. And if we get some exception, we want to handle that. In this case, we just like rethrow the exception, in order for it to bubble up. So nothing very complicated here. The other thing I need to do is I have to configure that worker to be able to access my cloud instance. So you can do that in the typical Spring way. So for example, you could override that via environment variables. You can use like runtime parameters to the program. So there are a couple of options. In my case, for development, the easiest is just to add it to the application properties, because now I can directly start this worker, and just to show that there's no magic involved, we just use a library that is able to connect to Command Cloud. It starts up pretty quickly, and it already executed the one waiting service task. Hooray! So if we go back, operate, what you can see is that this is now finished. So if I go back to this, you could see that between starting it and finishing it, there were 9 minutes, which was basically because I finished the other recording, started the new recording, talked a little bit, and so this took 9 minutes, okay? If I start another one, probably I start a couple of them, because we have other programming languages as well. So if I go back to my operate, I see that there are now 6 process instances pending. Okay, I need to approve a couple of them. Let's do that quickly. I agree that it would be probably handy to have a form here. But it's kind of a bit of brain relaxing to do this for a couple of these tasks. And this is not normally how you develop. I mean, then you probably write some test case and do other things than just clicking through, or probably start processes that are pre-approved or whatever. A couple of options. So I think that should do the trick. So now I have a couple of them actually waiting in celebration. Okay, that was my bad. I was so excited to approve all of them that I didn't think about that. As soon as I approve them, I have the worker running, so it immediately approved them, right? And actually, most of them, hang on, we take one of the latest, and that should be pretty quick, right? So a couple of milliseconds. So immediately moving on. And that's, by the way, also one thing I'm discussing regularly. So this is not a super slow setup. even if the workflow engine is in the cloud and you're subscribing to it, it doesn't mean like this takes forever or adds latency in a couple of seconds or whatever. So that's actually pretty cool. So we have a couple of these approved. You can do the same thing. I stop this for now. You can do the same thing in other programming languages. So for example, if we look at C#, same idea. There's a client you can use. It's a NuGet package which you can use. And then you basically can connect to Common Cloud. Again, you use the credentials we have. Create a new worker to celebrate, and then you basically pass in the handling code, and the code is more or less exactly the same what we did in Java. So not a big difference here. Okay. And finally, also for Node.js, same thing. There's a client library you can use. You simply reference that, and then you write a bit of code where you basically connect to Common Cloud. And let's quickly do this. As the last one, client ID. And I think you got the trick. So if you prefer grabbing a quick coffee before we continue in the training, that's fine as well, of course. But I'm always a big fan of showing, hey, this is really working. And then I create a worker to celebrate. And again, I provide the code, which is called whenever I have a service task waiting there or a process instance waiting at the service task. So let's start this. If you do it the first time, you do an npm install to get all the libraries. But I think that's clear if you do Node.js. So it's now waiting for tasks to happen. So I might run out of tasks actually. And this time we can maybe have a look at that. So I want to improve this. Okay, this is a bit too small. Approved equals true. Zack. So as you can see, it immediately got celebrated, right? What you can even do, by the way, and this is a bit harder to show here. And what we can maybe do quickly, because then it might be easier. And just as a remark, this is also my idea why I want to do this lab. So this gives you possibilities to play around with the technology, with the behavior, to get a deeper understanding of what a workflow engine is and how it behaves. And this is the main goal of these two labs. So it's not so much about learning, hey, how can I do a service task with Common Cloud again? Yeah, so what I do is I bypass the user task for the moment. So I simply want to celebrate, because that's the biggest fun. And as you can see, I celebrated in Node.js, celebrated in Node.js. Now I celebrated in Java as well. So what you can see there are now competing consumers, okay? Which is exactly what I would expect, because both subscribe to the same service task. It's really like a queue in messaging, and you have multiple subscribers. So they're competing, and the task gets distributed. And that also means you can scale up these workers as you want, by the way, or you can scale them down. You can throttle the throughput if you like. So we had customers in the past doing whatever PDF generation, and they have a license only for one PDF at a time or something like that. So you can throttle the load. So you have full control over the behavior here. Okay, so that was lab 2. So I hope you enjoyed that as well, as much as I did, and I probably keep doing that for a while. And yeah, and then we have a quick coffee break, unless we are a bit short in time, but I probably announced that in the training. See you back there. Thanks for watching.